Yeah. So it'll be on YouTube sometime next week. Our work is broadly situated in the application of computational tools to assist decision-making in public health. And we work in a wide variety of areas across the domains of chronic disease, infectious disease, zoonoses, and some behavioral risk factors like smoking, et cetera. Some of the conditions we've worked on are listed up there. With many of these, perhaps with all of these, we've been doing our work with AnyLogic, both for system dynamics, for agent-based, and for a wide variety of hybrid models. We also have been doing work in recent years quite a lot with elements of what's increasingly being known for better or for worse. I think for worse is big data. So we have ubiquitous sensing platforms that can be used to pick up contact patterns in the population, people's mobility patterns, levels of physical activity every few minutes. And we make sense of a lot of them using AnyLogic as a key component. So we simulate, for example, contact networks that we pick up on our phones during the flu pandemic using AnyLogic to understand the implications of that for flu spread and compare the results to clinical data. We also make, as Mark Page had kindly noted, a lot of use of Bayesian methods, Markov chain Monte Carlo techniques, hidden Markov models, which work very, very well with agent-based models and several different capacity-based nets, et cetera. I'm not going to be talking about all that stuff except to note that there are great possibilities there, and we have a wide variety of types of models to use. So within this talk, I had a variety of points of advice I was hoping to deliver. There's a broad set of them. I think there's an 11th thrown in here, but I'm hoping actually to at least get through the first two. Because for those, I have some presentations to do which involve tools. And these are areas where I've seen modelers really struggle and where I think alerting folks here who are working day in, day out as simulation modelers about a few tools may make a material difference in advancing the efficiency with which you can verify the correctness of your model, identify performance problems, debug issues, bugs with your model that you've seen through failures, et cetera. All of us who have used AnyLogic will probably know that things go wrong from time to time. What may initially seem like an emergent behavior turns out to be a defect in the model. Sometimes the model is ungracious and simply throws a null pointer exception or simply disappears in a preemptive way. So we've all probably gone through and marked up the model with trace-ln statements or system.out.println or other statements so that we know what's going on in the model in an attempt to figure out what's going wrong. Where is it having trouble? What is going wrong there? And it's a fairly arduous process, a fairly time-consuming process, and one that involves a lot of markup of the model that often has to be removed later. Within computer science, we talk about logging, not as an activity focused on old-growth forests, but as a process of recording a record of a program's execution, particularly salient sort of details of the execution that have particular importance. By recording this systematically, we can go back and diagnose in a forensic sort of way what went wrong where. When was the model getting off base, and when did it crash? At what point? And that gives us clues as to what may be going wrong. And I give a plug here for Log4j that some of you may have encountered. Log4j is a Java logging framework that allows you, by inserting a set of statements in your model on a one-time basis, all you have to do is flip a switch by changing a configuration file, and you can get it logging data to output it from the model. You can flip the switch again, and the model won't output anything. So it's a very easy way to sort of get it to output a large amount of information about what's going on. And it's very easy to use, comparatively speaking. It's quite similar to using other elements of AnyLogic in terms of level of coding involved. So you can simply ask the logger, hey, issue a warning about this, or issue some information about this. And you can tell it what level of information, how detailed do you want those messages to be, and how large grain. But I'm going to be talking with you today with some relish and with some pleasure about a little technique that we've been experimenting with for the use of automatically doing this logging for certain types of events. So with your leave, what I'm going to do is I'm going to run a model here that is a very, very simple sort of demo model where I'm going to illustrate the ability to sort of automatically log certain types of events on your model without the need to mark it up, without the need to actually go in and insert any sort of code to ask it to output certain types of information. So this technique is going to be running on a model of mobility-driven contagion, which I'll run out for you here. And you'll see that these agents are moving around and they're bumping into each other. When they bump into an infectious agent, the agent that bumps into it, if it's susceptible, may get infected. So fair enough. So what we're going to do now is run that model, and we're going to do so selectively requesting that certain types of information about what's going on behind the scenes get reported. So specifically, and I'll pause the model while I show you this, over here on the left-hand side, what I've done is put some buttons and some checkboxes that will allow us to request information be printed out and what sort of information we want to print out. We'll also be able to select particular agents on which we wish to report salient types of information. The types of information to be reported include things like when an agent enters a state, exits a state. It doesn't matter which state. They're all automatically handled. When a message is received, when a message is sent by that agent, when an agent is created, when an agent is destroyed, and when the agent receives a direction to move to a certain destination. We catch all those automatically. Wherever they are in the code, we don't have to go there and say, print out, the agent has been asked to go here. This is automatically picked up by this framework. So I'm going to unpause this model, and I'd like to draw your attention to this console area down here. And because of limited screen real estate, I'm going to, I guess, do so over here. So I'm going to turn on tracing to this model, and you'll notice that all this information is being output. I'll stop it now. You'll notice that information is being output on model messages being sent, model messages being received, that one agent is entering a certain state, and it indicates which state they're entering. And if you go and you look at the agent, you'll find that there's two different state charts and states that they're entering and exiting from those states are reported. You can see when certain agents get various messages. So I'm going to unpause this model again. That information will continue, but I can narrow it down. For example, I can say, I'd only like to receive information when agents are being told to move to different locations. And that will be reported there. Or when, for example, certain messages are being sent out by the agents. I can toggle this off for now, allow the model to simply run forward here. And we will then go click on a particular agent. Let's take this red agent here. And I'm then going to toggle this on again and request information. And fundamentally, now we'll get information about when that agent changes state or when it's sending messages. And here you could see that particular agent I happen to pick is sending a whole set of messages off. The key point to say here, folks, is you can get X-ray vision on your model. You can see what it's doing behind the scenes without having to go change a line of code in that model. You can enable that, you can disable it, and you can do so across the whole population, and you can do so at the level of a particular agent. This code, I'd be glad to share it with anyone. We've done this, we've accomplished this with a technique known as aspect-oriented programming. Fundamentally, all I just need to do is to give you a couple files. You can put a single line in a certain place of your model, and it's off to the races for certain types of tracing. So anyway, time's up? Time's up. Okay, well, I had another nice tool to show you, and perhaps I will segue off while just showing this tool in operation, a profiler that shows where your code is spending its time, what particular functions within your code, for example, this code that I created, are taking up different amounts of time, and allowing you to see where the performance bottlenecks are. Are they in certain types of events? Are they in certain types of certain functions? or are they associated with a visualization? I regret, ladies and gentlemen, I won't have time to show you that. Rest assured, that content will be on YouTube as well.
So there you go.
Thank you very much.
Thank you very much.